So here we are for the 5th of my LED lamp teardown videos, and this one I'm going to look at this R80 reflector. We look at what it says on it. Lightwell. Let's focus that. E27, which is the base, the Edison screw 27mm, R80, which is the size of the head. And it's 2700 degrees K, which is normal, and 85 to 265 volts. This, I said before, was an interesting, quite wide range of voltages, so it's obviously got a switching regulator in there with quite a wide input voltage range. Now, I did previously just take the top off and observe that that was fairly straightforward to do. I put it back again because I couldn't remember exactly what had failed in this bulb. So I put it back and put it back in the original socket in the kitchen, and it was, well, for a little while it was fine, but when I left it, it started flickering badly. Now, sometimes these just flicker with just a few of the LEDs coming on and off, but in this one it looked as though the whole array of LEDs was all flickering, so it looks though maybe it's a problem in the control circuit in the base. Now, to get the top off, I in fact superglued it back on just while I put it back in the lamp in the kitchen, just for safety. So this iFixit Jimmy, they call it, is one of my most useful tools. And that should bring this off quite easily. Yes, it snaps off. I just put 4 little spots of super glue on. Okay, so getting in here, getting this out proved to be a little bit tricky. Well, it wasn't difficult, but it didn't come out without a little bit of help. I tried some of my Loctite detach, and in this case, unlike another one where it just ran all over the place, I could put it in the little gap down there and just run it around, and after a little while I managed to lever it out. Need something a bit stronger than that. Use a screwdriver, and I managed to lever it out without too much difficulty. There, it comes straight out. And inside we've got this little controller here. Okay, before unwrapping that, that's going to be interesting to see what's inside there. Let's test some of these LEDs and see what happens when we try and test them with my multimeter. I've got my multimeter on the diode range, as I normally do. There's not really room for that only, but it's not going to show anything, but I'll put that there. Now, I need my close-up glasses for this. Let's have a look. Well, first of all, how many LEDs have we got here? Well, if you observe, there are 5 groups of 4, and in between each of these groups of 4, we've got 6. So that makes 10 groups, 10 in a group, and we have 5 of those groups. So that's 50 LEDs. Okay, that's quite a nice round number. Now, if we try, see what happens if we try lighting any of these up. Let's try one of those radial. Nothing there. It probably needs to be the other way around. There we are. Oh, 2 lit up together. That's interesting. Maybe those 2 are in parallel. Wonder if those 2 are in parallel. Yes, those 2 are in parallel. So it looks as though they're all wired in pairs. That's obviously the wrong way round. One of these must be the right other way round. Yes, there. Those are lighting up in pairs. Those are lighting up in pairs. So we've obviously got 25 pairs of LEDs there. Right, I think previously I did test them and all the LEDs seem to be okay. Well, just with a little bit of power like this, they're not going to fail, but when they start flickering, that's when they start getting hot, and the heat obviously causes either the bond wires to fail or the LED chip to fail in its bond against the substrate. Right, okay, so I haven't looked in here before, so this is going to be interesting. Unwrap this little Christmas present. There's the end of the tape. Difficult to get into that little book. There it goes, okay. Let's see what's inside here. I hope this tape isn't leaving a gooey, sticky mess as old tape sometimes does. Okay, that's torn. A couple of electrolytic capacitors there. I think I'm going to use my little craft knife for this. Let's cut it down there, so hopefully I won't damage anything and take the rest of this off. Right, okay, interesting. Let's take a closer look at that. See if I can focus in. Well, 3 electrolytic capacitors. Don't know whether we can see the markings on them. Don't see. Looks like a manufacturer's marking of some sort. Can I get any closer? It's too close to focus. Looks like the manufacturer's name or something there. Okay. And we've got a little either inductor or transformer, and that, if we look on the other side, that seems to have 4 connections to it, unless 2 of them are just to hold it physically in place. Now, looking more carefully, no, I was thinking there wasn't one. Yes, there's definitely a connector, a pin under there. So 1, 2, 3, 4 connections there. I wonder if you can see what that chip is. Again, find my magnifying glass and perhaps I can see it better then. This isn't working too well. Oh, that's it, okay. I think what I'm actually going to do, I'm going to pause this and put a close-up lens on my iPhone. That's right, there's the close-up lens on. Part of the problem was that this metal disc was reflecting a lot of light. Okay, so with the close-up lens, I'll be able to see that now. Difficult to see what it is exactly. And that is, right, okay, so that's going to be your bridge rectifier. And there is what looks like, it says D5 against that, so that's the Schottky diode almost certainly. Right, U1A, an integrated circuit normally has a component reference U something. Okay, and let's look at the other side. Is there anything there? If we lift up. can't see anything underneath those capacitors. So it's a relatively straightforward circuit then. Right, I'm going to pause this again. Ah, no, can we see that? 105 degrees is that? That's the temperature rating. It's got a bit of a... That's some of the residue from that tape. Right, I'm going to pause this for a moment and I'll take a closer look at the number on that chip. See if I can see it in a better light with my eye loop and look it up and see what it says. Okay. Well, taking it over to the window, I could see with my eye loop that it had a number TV2216 on it. And I've been looking for that with Google, and unfortunately it doesn't seem to come up with anything very much. There are various data sheets which it comes up with, and some of them seem to say a fast recovery diode, which is another name for a Schottky diode, but nothing which looks like this. And it's actually an 8-pin package, and some of the search results come up with SOP8, which is this small outline package, 8-pin, which was seen to be right, but when you look at the data sheet, it doesn't come up with anything at all like it, or it just comes up with here's how you can buy 5,000 of them or something like that. Okay, just before we go any further, right, that's broken off, that wire there, but in fact they're both broken off. Well, that's going to help very slightly, because the next thing I wanted to do is check that those two wires go straight through to the base with nothing in between, so that's going to make it a little bit easier. So put a little bit of the wire insulation off. I thought I was going to have to find my wire strippers for that, but I should just now be able to connect to each of these. That's not holding very well, but never mind. And okay, that's upside down, but never mind, you can get the idea. I'll put that on the lowest voltage continuity range, and let's see whether, yes, there's continuity through to there but not to there. And if I attach that to the other one, I think that's the other one. Now that we should get continuity through to the base. That's right, you hear the beep, and if I hold it on, the meter is saying 0.8 ohms, so basically there's nothing in there. Some of these, like one the other day, seem to have a resistor in there, which presumably is just to reduce the inrush current when you first switch it on. Okay, so the next thing we can easily do is test the bridge rectifier on there and that Schottky diode and check that they're okay. They must be pretty much okay, because it does work to some extent. Right, that's back on the diode range, and getting my tip pins on the test probes. Right, we've got a resistor in there which is just reducing the inrush current. Right, and power comes into there through that diode and then into the AC input of the bridge rectifier, and then goes out through there to the other side of the base of the lamp. Right. Right, okay, so there we got 0.6 of a salt. Right, okay, so from there to there I was doing this wrong, so that'll be the other diodes. So from there we should have a diode going from both the inputs, the AC inputs, to there, that way round, and the other way round we should have inputs from there, diodes from there. That's it, 0.6, 0.6. So we've got a diode going one way from both of those to there, and the other way from both of the inputs to there. Okay, so that's okay. Let's try this Schottky diode. Nothing that way, and the other way we get 0.496, half a volt. Okay, so that Schottky diode is okay. Right, the next thing I need to do, and I'm going to have to pause the video again for a minute, is unsolder those capacitors and see what they say on my little component tester. Okay, let's try that. Okay, so here we are again. I've now got those three capacitors off this little board. Two of them are marked 6.8 microfarads and 400 volts. Don't know whether you can see that. The actual marking is not visible from the way they were on the board. Doesn't seem to want to focus. Anyway, take my word for that. They were a little bit tricky to get out because on one or two of them the holes that they were soldered into seem to be through-hole plated, so that the doesn't seem to want to focus on this. I think you can just see there's a bit of solder which was from the other side of the board. Definitely not wanting to focus. Anyway, I think you can just about see on there's a little ring of solder still which came from the top side of the board, and applying the iron to the other side of the board had trouble melting that, and one or two of the others, that one for instance, yes, you can see there against that background it was bent over, which made it difficult to pull out. Now sometimes when you pull too hard on the lead it breaks something actually within the capacitor, so I think we probably had one before where the capacitor appeared to be open circuit, and it might have just been a broken connection inside when I tried to pull it out. The other thing to notice, really do need this to focus on, that's focusing. I think probably the capacitors were too small to actually get my smartphone to focus, is that the board is distinctly discoloured, which is not a good sign. It looks as though this has been running quite hot, so that wouldn't have improved the life of those capacitors at all. I've made a note, right, okay, so that I've made a note of which way round those capacitors went. Not sure you can see actually on the board whether it gives the polarity, not very clearly, but I made a note because should those capacitors be all that's wrong with this, then I could actually replace them and maybe get this lamp working again, which would be a first. Okay, so let's have a look at these capacitors. I've got my tester here. Where's the other one gone? Oh, the other one's there. Right, this slightly thinner one has 2.2 microfarads, 400 volts, and let's see what happens if we put that on the tester. Okay, press the button. Oh, 35 picofarads, that's not good. That's hardly anything at all. That's just the stray capacitance. Try again and see if it's going to do anything. No, that seems to be pretty well open circuit. Well, that could be part of the problem, I don't know. Or as I say, it could be that I broke something inside on pulling the capacitor out. Right, let's try this one. You'll notice I'm not taking any particular attention to the polarity. Which of these will produce plus and which will produce minus, I don't know, but it's only a few volts, so it's not going to damage this capacitor. Right, okay, here we are. 593 picofarads, which that's definitely pretty off as well. I presume those connected properly. Try another pair of pins. Basically this has got 3 connections in here, and you can choose any 2 if you're testing a 2-terminal device. See what that says this time. Yes, between pins 2 and 3, I've got it on 2 and 3 there. 590 puff, which is, if I actually take this off, does it give anything at all? No component found, so there is a minimal capacitance in there. If I try this one, right, what's that one say? 25 puff. Well, is that the problem? It could well be. Or it could well be that I damaged these taking them off. What I might actually do, these are cheap enough, 400 volt capacitors is not something I tend to carry, because most of the work I do is just low voltage stuff with Arduino and Raspberry Pi and so on, so I don't usually use that sort of thing at all. So if I order a few more capacitors, and then maybe I shall put them in and see whether we can actually get this working again, which would be rather good fun. Okay, just one other thing to notice. Before disconnecting the actual luminous head, I made a note of which of these wires is which. One of them is, you might be able to see, it's got a stripe down it, and the other hasn't. Now the stripe down it is one of these 2 connections, which is marked plus. I don't know whether you can see it. If I get the right light, you might just get it. Difficult to see, but that one there has got a plus against it, and that was the lead with the stripe on it. So if I get some more capacitors and try and fit that, then we'll see what happens. Well, I've now got some spare capacitors, a 2.2 microfarad to replace this one. It's a little bit bigger. Whoops, dropped it. There it is. And I couldn't get the 6.8 microfarads, but the value is not really critical so long as it's at least as great. So I got some 10 microfarads, and they should be just fine. They are, again, somewhat bigger, so fitting them onto this board is going to be a little bit of a juggle. But there's plenty of room in here, so I think that shouldn't be a big problem. And I'll fit those. I'll have to wrap this. It was in this insulating tape originally, but I'm going to have to do better than that. So I've got some heat shrink sleeving, and that should do to make the whole thing safe. Now I'm going to solder that up, see if I can wrap those capacitors on in a suitable way and put it back together again, and we will see whether it works. That will be the moment of truth. Well, I didn't think you'd want to spend 10 minutes just watching me soldering these capacitors up, so I just took photos of the process on the way. As I said before, these capacitors are a little bit larger than the originals, so they didn't fit terribly well, but I thought there was going to be plenty of room for them, so I left them like that. There we are, having wrapped the little module in the heat shrink sleeving, and indeed there was in fact plenty of room to tuck it into the lamp housing. So I then put it back together again, super glued the top back on, and tried it in the kitchen. Now this was going to be the moment of truth with a little trepidation. I didn't think it would blow the house fuses, but there was always that possibility, hopefully pretty remote. And I switched it on and voila, it worked. And in fact, I'm recording this last bit of the video a few days later and it still seems to be working. So I think probably what happened was that those capacitors were rated at 105 degrees, which is pretty common. I think probably if I'd been able to get them, it would have been much better if I could have got some higher temperature ones. You can sometimes get them rated at 125 degrees or something like that. So I think probably what happened was that the heat gradually caused those capacitors to dry out. They contain a little bit of moisture in there. They're electrolytic, which means that they involve a process of electricity passing through a solution in order to form the insulating layer. And if that liquid dries out, then they cease to operate. And I noticed, as I said at the time, that there seemed to be a little bit of contamination on the board, and I think that's probably the liquid which had escaped from those capacitors and corroded. Well, one of the wires I noticed was slightly corroded and there was some contamination on the board. So that was almost certainly evidence of those capacitors drying out. And the ones I put in are slightly bigger, which might give them a little bit more life. Slightly, well, who knows? I got them from eBay, whether they'll be any better quality. They were the same temperature, so I don't expect them necessarily to last forever. But there we are. Success. This is the first time I've actually managed to repair a light bulb. Hooray!